Okay.
Hey, how are you, Walker? I can't hear you. I heard you for a minute, but now I can't hear you. I can hear you now. Are you there?
Hello?
Walker?
Yeah, hey.
Hey, how are you?
Getting everything situated.
Oh, okay, no problem. I understand that perfectly.
The microphone on my thing was not working too well, so I went and got my headphones.
Oh, okay, cool. Now I'm looking for my. Oh, there it is. I'm looking for my stylus. That's what I couldn't think of the word. I'm looking for my stylus. Just in case you have a question you want me to work something out.
Yes, currently I've been going back over the review packet.
Yes, sir.
And I've been putting question marks wherever I found a problem that I couldn't just know off the top of my hand. And I don't know, so far I think everything's been pretty good. Most of the stuff I know I need to review. But there have been a handful of questions.
Okay.
Like number 21 on the review packet.
All right, let me get there. Right.
Yes.
Right
So,
there. Okay.
yeah, so f of x equals negative x plus 3, and g of x equals x minus 2.
Yes, sir.
So when you're multiplying the two together,
You're not multiplying on this particular one. This F, this is called F composite G. See how that little thing, it might be difficult to tell, but this little thing right here in the middle is not a multiplication. It's a composite sign. So it literally is this. It almost makes it look like fog, like that.
Mhm.
And how it would have looked in our homework, it would have looked like this. And then the -3 would have been like that. Something like that. Okay. So this basically means when you see that little circle on the in case there is that on the exam, it's called a composite function. And what that means is you're going to plug in that -3 into the G function first. So you would do -3 minus 2, which is going to give you a -5. And then you would take that -5 and plug it into the F function.
Oh, I see.
Okay, so you take the result of the G, so then that would be -5 plus 3, which is going to give you a +5 plus 3. So my final answer is 8, and that is D.
Okay.
Okay?
Yeah, yes, ma'am. I think I got it now.
Does that help?
Yes, ma'am.
Okay. So that's a very different symbol than multiplication. So
Yeah,
you got to just be very aware when you're taking the exam. Is it a multiplication or is that a composite symbol? Because they are close, and I do see where that can be very confusing, but that's actually a composite symbol. And we talked about it, but way back when we were doing these, we talked about it a little bit in class, back when we were dealing with those functions, because I want you all to be aware of that, because most of the time on standardized tests and stuff like that, it will be written like that as opposed to all of the parentheses. Does that make sense?
Yes, ma'am.
Okay. So I want you to be familiar with both styles of syntax for functions, but because it seems like both are used, but in different places.
I think I'm starting to understand a little better. So,
okay.
if I can look around a little bit.
Okay, no problem. I'm here till 1:45.
I wonder if anybody else will join in. Oh, but I am actually getting my braces off today, so I'll probably be leaving around 1:20.
Okay, I mean, that's fine. You know, you can come and go as you please. So,
Wonderful.
but if you have, if you have any other questions, I can handle them now. And it's like a one-on-one tutoring session, Walker.
Yes, ma'am. So let me see here where the other ones are, so I can erase that. And I had a few other questions if I can find them on the review packet. I also have my book open. I was searching for some other stuff like that.
Okay, while you're searching, I'm going to write this word on the screen.
Mm-hmm.
So if you ever need to Google it or anything like that to look at the varying types of syntax for that particular style of function, it's called a composite function.
Okay.
And it's virtually where you're solving for one and putting that solution into the other.
Okay. Great. So my next question, let me see here, what was it? Number 10. Find the value that completes the square and then rewrite it as a perfect square.
Okay.
I'm still a little confused about just how to do that.
Okay.
I'm
going to write up here, half it.
Mm-hmm.
Maybe I shouldn't write it with the fraction. I know fractions bring the fear of God in all of you people. I love you, but y'all, it scares y'all. And then square it. Add it. And the term you're going to have is the 42, is the B term. So basically in books, they write it like this, B over 2. So half it. And 42 in number 10 is the B term. So what's half of 42?
21. I saw that and I actually ended up selecting C for my answer because that's what I suspected it was.
So what happens when you square 21? What do you get?
Was it like 441?
Yep.
Yeah, so then I suppose that would equal D then. You could
yes. So the halving it is the 21 part. The squaring it is the 441, and then you add it here. Half it, square it, add it.
Gotcha.
And I tried to make it a little mantra so that, like when you see it, whenever you see these words complete the square, think in your head, half it, square it, add it.
Alrighty. Thank you.
It's a little, sometimes a little jingle can kind of help you get over the hump, half it, square it, add it. So the half part, whatever the half was, which was the 21, that's the part that goes in the parentheses. That's the 21. And then whatever you're adding to the end, which here, right there. Half it, square it, add it. Does that help?
Yes, ma'am. Okay. Alrighty. This has been really good. I'm learning a lot of things from right here. So, as far as number 11 goes, I remember a lot of this very briefly. Some of the stuff I got a little more than others. But most of this is just going over, recapping, making sure, I remember all this stuff because it's a lot of math.
Yes, it is. So I think if I were tackling this problem, what I would do first, obviously, is handle your parentheses, because technically, according to PEMDAS, that's what we should do. So that -1 there, all that really does is gives you, it tells you to apply the reciprocal right here. So for here, all that means is I'm taking every single one of these terms, because I would apply it to the 2. The key thing to remember, Walker, is that that -1 applies to everything inside the parentheses, including that constant.
So with that,
Hey, Momo, I guess you'll have to get my debit card.
Okay, thank you. You can tell me now.
Okay, so then you just, since I'm applying it to everything there, 2x y squared, because really all that happens with that -1, because if I raise that to the first power, none of the values would change, would it? Because anything raised to the first power is really itself. But the negative part drives it to the denominator, because that negative means to make it a fraction or to give the inverse of that. So that part's done. Okay?
Gotcha.
So now with the second two, that xy cubed times xy cubed, I basically have to take the exponents and add them together. Love you. Y'all be careful. Love you. Bye, Maggie. Say goodbye to Walker.
Bye. Bye, Mackenzie. And others.
Yeah, that's Maggie Schaefer and Mackenzie. It's both.
Oh yeah, I know her.
And anyway, so then you're just going to add the exponents. So the understood exponent on the x is 1. So that's going to be 1 plus 1 is 2, and 3 plus 3 is 6, right?
Yes, ma'am.
Okay, so now I have 1 over 2xy squared times x squared y to the 6th. So basically, that just makes it end up looking like this. My next step looks like this. We're not done yet, though. Like you said, it's a lot of math. And now what I have to do, this is a division problem now. So what I have to do is subtract my exponents when it's division. So if it's multiplication, you add. If it's division, you subtract.
Okay, so then you just take the x squared minus x, which would just equal x, and then
and if it's a positive, it remains on top. And obviously the 2, there's nothing to go with the 2, so the 2 stays down on the bottom. 2 minus 1 is x, so the x stays there, and 6 minus 2 is
4.
So that would be there. So my final answer, I shouldn't have written this all the way over here, but I didn't know what was going to happen, you know? So I wanted to give myself room if I needed it. Should be x, y to the 4th, all over 2, which is D.
Nice. Thank you.
Okay?
Really
so I broke it down into a lot of steps, but that's, in all honesty, Walker, if this were my problem and I were working it on the exam, I did it exactly as I would have done if it were my own personal problem. For me, I really can't skip a lot of steps. I have to prove to myself each step of the way that I've gotten to a certain point. Does that make sense?
Yes, ma'am. I guess my dad always said, there's always more paper. You can never write too much or too big.
Yes. And that's, for me, that's what I need to do. We're blessed to have that, and I realize that, but I have to take each step of the way. Because if I start skipping steps, that's where my simple errors get in, and I end up messing myself up. And I know that I understand the principles of what I'm doing and the concepts. It's just that if I start skipping steps, that's I create problems for myself.
Gotcha.
So I tell you what, why don't you walk me through, no pun intended with walk and walker. Why don't you walk me through number 12, please, given the principles that we just covered? What would I do?
Okay, so we have a -2 in there. So let's see here.
That negative part's going to do what?
It's going to put it over 1.
Yep, it sure is.
So if you have
good job. So then I would have 2 squared x squared. Why do I have 2 squared x squared, Walker?
Because it's a squared in the
right.
The -2.
And I have to do everything, including the constant, correct?
Yes, ma'am.
Okay.
So then at that point, you would try and do subtraction but there's not really anything to subtract up there. So, tricky one. I suppose 2 squared would be 4.
Yes.
So you could do that, and the final answer should be around C.
Yes.
Which
that's
is
it.
Whatever.
Perfect. You did it.
Hooray! Woohoo!
All right. Cool.
Alrighty. So I think
13 and 14, my biggest caution for you is to make sure you distribute that negative to everything in the second parentheses on both of them.
Yes, ma'am. And then whenever I have something like that, I do the plus negative, and then I
there you
put a
go.
little negative sign to
Yeah.
each of the I don't know if you can see it, but I put a little negative sign to each of the things inside the parentheses, so that way it kind of reminds me that they're all negative.
Okay. All right. Good idea. Smart thinking.
Alrighty. So I think, there's only a few more left that I'm a little more that I have some questions about. One of them is 8.
All right.
So simplify and remember to rationalize the denominator. So when I did that, I didn't know if you wanted to like simplify or something. So I started taking 50 and factoring out into 25 and taking the 5 over.
You're perfect.
So then that would equal, let me see, it would be 5, 6, the square root of 6 over 10 square root of 2.
10 over square root of 2. Yes. Okay. And if to rationalize the denominator, what would I do?
Let me see, you're going to take the 10 and put it over? Or
well, I mean, you can reduce that, but to rationalize the denominator means to make sure there's no radicals in the denominator.
Got it.
So I would do what?
Would you
get rid of that 2? I'm sorry?
Would I square it?
Well, you could square it, but then you're working with some really big numbers. You only have to multiply it by the square root of 2 over the square root of 2. Do you understand why?
Yes, ma'am, because that's 1, and if you multiply it by times the bottom, then that just gets rid of the 2.
Yeah, so basically, that is going to give me 5 times the square root of 12 over 2 over 20. But what happens with that square root of 12? Can it be reduced further?
Yes, ma'am.
Okay, what can it be reduced to?
3 and 4, and you can factor out the 4 into, let's see here, that should be 10 square root of 3 over 20.
And then that will reduce
to
so 1 over 2.
Yeah.
So that's going to be the square root of 3 over 2.
Sweet, so that would be letter D.
Yep, that's it.
All right, thank you.
No problem. You kind of did it yourself.
I think I had a lot of help from you, though.
Well, I was going to say, I mean, you walked me through it.
Yes, ma'am.
I mean, you know what I'm saying? I mean, I had to, prompt you a little bit, but I feel like you got it. It wasn't like you weren't like, oh yeah. I mean, I think you were remembering. So I feel like you'll remember tomorrow. You're doing good. You're doing great.
A lot of this stuff just kind of needs a refresher for me, but some of the stuff I'm a little more hazy about.
Yeah. How about number 9? Do you know how to rationalize that denominator? Do you remember that?
Let me see here. A little bit.
Does the word conjugate ring a bell or just bring terror into your life?
A bit of both.
Okay. So what would the conjugate, and when I say that, what do you think I mean when I say conjugate?
I am not sure.
Okay. All right. In order to rationalize a denominator for an imaginary number, you're what that is I'm looking for the conjugate of the denominator. So I'm going to multiply. Can you see that okay?
Yes, ma'am.
Okay, cool. I'm going to multiply the top and the bottom by the conjugate of 3 plus 5i, and the conjugate of 3 plus 5i is 3 minus 5i. So I'm going to multiply both the top and the bottom. Hold on, let me see if I can write a little more clearly. Okay.
Got it.
And now to multiply the top and the bottom by that, I'm going to FOIL. Good old FOIL. So -6 times 3 is -18, right?
Yes, ma'am.
And -6 times a -5i is a positive 30i, correct?
Yes, ma'am.
All right. Now, -2i times 3 is -6i. And -2i times a -5i is a positive 10i squared. Oops. You can't really see my squared. I'm really sorry.
No, it's okay. I already wrote it down on here.
You did? Okay, good. All over, and then 3 times 3 is 9. And 3 times -15i is -5i is -15i. And a 5i times 3 is a positive 15i. This is why you multiply by the conjugate right there. And then 5i times a -5i is a -25i squared. All right, now let's do some combining. So I've got a 30i and a 6i that can be combined. So I've got -18. And then 30i combined with 6i is a -6i is a positive 24i. Now, when I have a 10i squared, I squared is what? Do you remember?
Isn't it -1?
It is -1. Good job. So that's essentially saying 10 times a -1, which is a -10. And now, I'll do that in the next step. Let me go to the bottom. This cancels. And now we have this -25 times that I squared, which you told me was a -1, right?
So wouldn't that equal positive 25?
That would be a positive 25. And if I combine that with this 9, what would that give me?
That would be a 34.
It would. And then I have to kind of go back to the top, and I've got a -18 and a -10, which I'm going to make my final answer a different color. -28 plus, I might have done something wrong. Did I? 24 I. Did I do something wrong?
That answer is not on the...
Yeah, I know. That's why I'm like, did I do something wrong?
Let's see here.
So let me go back. Let's double check our math, my math.
Do you remember to keep the 10i squared?
Maybe.
Yeah, I think you did on that one. So that's a -10. Then -28.
And I got a -6 times 3. That's a -18. So that part's right, right?
Mm-hmm.
Oh, I know. We didn't do anything wrong. We can divide everything by 2.
Oh, gotcha.
So if we divide everything by 2, that gives me a -14 plus 12i all over 17.
Gotcha. Made us worry there for a little bit.
Yep.
Alrighty.
So you have the answer sheet in front of you?
I don't have the answer sheet. I have like all the questions.
Oh, at the very end, there's not an answer guide on the back?
Let me check. Oh, there is. Yep. Here you go.
Is 9A?
9 is A. Yes.
Yay, we did it, Walker.
Woohoo! Sweet. So let's see here.
And that one is a lot of math.
Mhm.
But once again, just take it step by step. Don't skip any. Bring lots of scrap paper with you, Walker.
Yes, ma'am. So I think the final question that I have, or questions, is number 4.
Okay.
Solve each equation by taking the square root. So I'm confused about like how to do that. Would you find, and if you took the square root of 7x squared, wouldn't that just be 7? Or I'm kind of confused about how to do
which
that.
number 4?
Do you think
Is that what you said?
Yes, ma'am.
Okay. Okay. 7x squared plus 5 equals 117. So I'm going to subtract 5 from both sides first, because you want to do PEMDAS in reverse. So you want to look for all your possibilities of addition and subtraction first. So then that's going to give me 112, right?
Okay.
Now I'm going to divide both sides by 7, right?
Yes, ma'am.
And then that's going to leave me with x squared divided by 16, yes?
Yes, ma'am.
And so the square root of both of those is x equals plus or minus 4. C.
Oh, I see. I see.
So what you want to do on like 4 and 5 is you want to get it down to where it's just x squared and a constant, like x squared on the left and a constant on the right. So you want to apply the principles of doing. Have you ever seen that before when I've talked about it? Like, does that make sense to you when you
Yes,
do
ma'am.
PEMDAS in reverse?
Gotcha. It's all
So
just
you know how
really
we had to
basic
work
algebra
out problems? You want to do it in reverse. So you're going to look for addition and subtraction first, which that's this 5. Then you'll look for your multiplication and division. And then you work on your groupings and your exponents.
Gotcha.
Which
So
is what we did on that final step.
For instance, like number 5, if I were to do all that stuff out, it should be letter B if I'm not correct.
Okay, well let's do it together. Let's it sounds like you've been all over it. So let's work it real quick. Work using these principles. So what was the first thing that you did?
You add 5 to both sides since you have a
rock.
-5.
You rock. That's awesome. Yes,
that
you
would give
do.
you 20, and then you divide by 4. That would equal 5, and then you have the x squared left over, so you'd get the square root of 5, which would be plus negative square root of 5.
You go. Sounds like you were all over it.
I think it was kind of like that aha moment as soon as you explained the first one. I was like, oh, that's how you do that.
Yeah. I love aha moments. It's a beautiful thing.
Yes, ma'am. Alrighty, so I think that really does it for the most part. Let me check one more thing. So as far as number 7 goes, could you walk me through that one more time? And I think that's like the last thing that I really need help with.
Okay, sure. Be happy to. It's just one of those that, that's also, like just there's a lot going on. It's like it's a lot of math going on. I don't feel like it's anything that you can't do. It's just it's paying attention to detail on those. I feel like is the very crucial thing.
Gotcha. So I was writing them out. I know very
What was
basic.
it? Number
Number seven.
7
Number
or
7.
6?
Number 7.
Oh,
I already did number 6, but for the most part, I think I got it down. I just couldn't quite figure out this problem. So first I took like a 4 and I multiplied it by -1, which is a -4. And then 4 times -36 is a negative
wait,
20.
it's a negative. You're multiplying 4 times a negative 3i.
Yes, ma'am. Did I say something else?
Yeah, you said 36.
Oh, my
So I
bad.
just wanted, so you got a negative 12i?
Yes, ma'am.
Okay, cool.
Then I took -2i and multiplied it by -1, which was a positive 2i. And then a negative 3i times -2i, which would be a positive 6i
Squared.
squared. Yes. Oh, I think that's where I messed up.
Okay.
I forgot the squared. So if you took that, and
You
you
could,
take the positive 2i, and you combine it with the negative 12i, that'd be negative 10i. And then you have the -4. And so if you had in this situation, if you had an I squared, would that be the -1?
yes. So
Okay, so
6
then
times the -1
is a
gives you the
-6.
-6.
And then
And then when you take the -6,
add it to the -4, that would be -10 minus, minus negative
10i.
10i, yeah. So that'd be number 20, 10. Sorry, getting kind of tripped up here.
So it should be letter D.
Yes, ma'am.
There you go.
Thank you. Thank you so much.
Not a problem. Is that it?
I think that's it. Yes, ma'am.
You're good on logs?
Yes, ma'am. I was gonna review it for a little bit. I think I remember most part.
Okay.
Looks
Well,
like
I'll
some-
be here till 1:45. So if you go and review those and you need me again, I'll be here till 1:45.
All right. Thank you so much, Miss Sparks.
Not a problem.
Have a nice day.
If I don't talk to you, I'll see you in the morning.
Yes, ma'am.
Okay? Have a blessed day.
You too. Hello? Hello? Hey, Miss Brooks, are you there? I was going to go over a few more of the logarithms.
Hey, Walker.
Hey!
I'm sorry. I was washing my hands. I was trying to throw something in the crock pot for my family dinner. But
That's
welcome
okay.
back.
Yes, thank you. So I was hoping to go back over, or go through a few more of the problems, especially with logarithms. As far as I went back and I finished up some of the review packet stuff.
Yes.
As far as graphing goes, it was kind of so recent. I mean, it's still kind of fresh on the brain, so I don't think we
Yes.
have to go much into that. But I was hoping to go over to find all the rational zeros and all the stuff for number 18. And let me see here.
Okay.
So we can start with that and go through up until we get to the graphs for some of the stuff.
All right. I'm writing it down. Do you have your calculator in front of you by chance?
Got it right here.
Okay. Two things that I want to do with you just to kind of familiarize you with everything. I'm going to go through it the long mathematical way, but I'm also going to show you the graphing calculator cheat way. Okay?
Okay.
The reason why I'm going to do that, I cannot guarantee that they will be that you'll easily be able to find them on the calculator, because I don't know what the problem is going to be for number 18, but number 18 is going to be to find all the rational zeros. So I want to show you mathematically and I want to show you graphically, because when we're looking at rational zeros, do you remember when we talked about in class, when it says to find the rational zeros, what is it actually saying? Do you remember?
No, ma'am.
Okay.
That was a little fuzzy.
Okay. That is actually where it goes through. Now I'm looking for my calculator. The X, where it crosses the X axis on the calculator.
Oh, got you.
I think I might have left it at school.
Well, that's not good.
I know. I hope it's in, I usually put it in my top drawer. But okay, so if you would, you know how to get to the graph part where it says
Yes,
y
ma'am.
equals? Okay. So go ahead and plug in 3x raised to the 4th power plus 8x raised to the 3rd power minus 30x squared plus 24x minus 5. And then hit graph. And hopefully, if your window's on standard, it should basically, in all honesty, look like, hang on, here's something I can do.
Desmos, yeah.
Yeah, I'll do this. And then I'll be able to more logically kind of walk you through what it is, because what I would like to do as we're covering it is I want to show you mathematically what it does, but I want to show you graphically as well. Oops. Like I want to show you the math part, and I want to show you what the equation is actually saying, basically, is what I'm trying to say.
So that's kind of what I got on my calculator. I don't know if you'll be able to see it. It's more pixelated.
It is what you got?
Yes, ma'am. It's very similar, only a little more pixelated.
Okay, hold it up again. Hey, cool. Okay, we're twins.
Yes,
All
ma'am.
right. So let's go back to this. Now, what I want to explain is if you get a pretty graph like this, I can't guarantee that the problem on the exam will be as nice as this, but if you get a pretty one like this, you can see right here. I don't know whether my stylus, no, it doesn't allow, oops. Please don't do that. I don't want to rewrite. How can I undo?
Hit the little button.
There we go.
Undo button.
Okay. Oops. What happened?
One here. Try hitting the forward button, like right
Okay,
there.
cool. All right. What I was trying to do is explain to you, it had the dots before. There we go. I was trying to explain that, see where the dots, the gray dots are?
Mm-hmm. Yes,
okay. You can see that that's going through -5, correct?
Yes, ma'am.
It's also going through, it's also hitting over here at about 1. Do you see where it dips down at 1? Like it dips down, touches, and then goes back up?
Yes, ma'am.
Okay. And it also hits about 1/3.
Mm-hmm.
Okay. Those are going to be all of your rational zeros. Wherever it crosses the x-axis or touches the x-axis are going to be your rational zeros. That's exactly what that question means. So algebraically, I'm going to show you what it looks like, but graphically, what that question is stating is where will this graph, or where would this graphical expression of this equation, where will it come in contact with the x-axis? That's what that question is. Okay.
Gotcha.
All right. So you see where it dips down to the x-axis and then comes right back off of it?
Yes,
do you
ma'am.
see that? Okay, that's going to be where there's a multiple. So now let's go back to the final exam review and look, see where it says there's a multiple of 1, multiple of 2. See that on each one of these?
Yes, ma'am.
Okay, that means that that's where it's going to dip down somewhere on the x-axis like that, which it doesn't look exactly like that, but you know that it's going to, like if it was a multiple of negative something, it would dip and go like that over here. It means it's not going to cross the x-axis when it's a multiple. Does that make sense?
Yes, ma'am.
Okay, but when it actually crosses the x-axis like this, that means it's going to be a rational zero where there's not a multiple. All right, so I've kind of shown you graphically. So in all honesty, you could maybe answer the question using your graphing calculator tomorrow.
Gotcha.
Okay, so that would be a good place to start. But if you couldn't do it graphically, it's giving you this 0 right here, which is -5, which that's where it crosses the x-axis, and we absolutely saw that. You know what I mean?
Yes, ma'am.
On the problem. Let me open. I'm going to go over here and I'm going to work it out. So now what I would do, I'm going to rewrite the problem up here. F of x, 3x to the 4th plus 8x to the 3rd minus 30x squared plus 24x minus 5. Okay, and it seems to me that it said one of the 5s was a -5, right?
Yes, ma'am.
Okay, so synthetically, what you would do, okay, because it's one of the zeros, we know that one of the factors is -5.
Gotcha.
Okay, and basically that means that x plus 5 is going to be a factor.
Mm-hmm.
But this is what you do. 3, 8, -30, 24, -5. Bring down my 3. Okay, 3 times -5 is -15. That gives me -7. -7 times a -5 is a +35. Gives me 5. 5 times a -5 is a -25. 24 plus a -5 is a -1. And -1 times -5 is a +5. So that gives me a 0, which I knew going in, since -5 is one of the zeros, I knew that I should come out with a remainder of 0. So now what I'm going to do is then, do you remember good old P over Q?
A little bit, yes, ma'am.
Okay, so that means I'm going to take all the factors of 5, which are plus and minus 5, and plus and minus 1, all over all the factors of 3, which is plus and minus 3, and plus and minus 1. So all those are a possibility. Plus and minus 5 over 3, plus and minus 5, and plus and minus 1. Because it would be 5 over 3, 5 over 1, 1 over 3. Oh, 1/3 is 1 too, isn't it? Plus or minus 1/3.
Mm-hmm.
Does that make sense?
Yes, ma'am.
That's all the possibilities of zeros that I can have. So I have to pick one of these as my next divisor, if you will.
Mm-hmm.
All right. But let's also go back here and talk about this for just a minute. I can, based on that, based on what my P over Q was, I can eliminate 2 answers. Can you tell me what 2 answers I could eliminate immediately?
C and D.
Well, C is definitely one of them.
Mm-hmm.
I could eliminate C.
Okay, and so
The other one would be what? Because 1/3 is a possibility, -1 is a possibility, 5/3 is a possibility. Is 1/2 a possibility?
no, ma'am. So that'd be A.
Yes, so C and A. I can eliminate those automatically. Okay? Does that make sense?
Yes, ma'am.
Okay. But now, I'm going to go back here, and I'm going to, because I'm going to make it easy on myself, I'm going to go ahead and use my 1 as my next divisor. Okay?
Mm-hmm.
So, hang on just one second. So I'm going to do 1. And then I'm using this answer right here. 3, -7, 5, and -1. So I bring down my 3. And 1 times 3 is 3. That's -4. -4 times 1 is -4. Leaves me a +1. And 1 times 1 is 1. Gives me a 0. So luckily, 1 is my answer.
Mm.
So one of my other zeros is 1. All right. Does that make sense or not really?
A little bit. I'm still a little confused. So with all that, that should mean that the answer is B, correct?
I believe it is. Yes.
Mm-hmm.
Because I've gotten a -5 is one of them.
Mm-hmm.
And now we know 1 is one of them. So And then what my result is 3. I'm gonna erase some of this up here. Did you get the P over Q and all that stuff?
Yes, ma'am.
Okay. I know there's a lot going on with this problem, but so now what I'm going to do though is to prove it all the way down, and I can get every answer for you, because I'm going to take the result of this, and this would be 3x squared minus 4x plus 1, and I'm going to factor it. 3 times 1 is 3. What two things can I multiply together to give me 3 and give me a -4 when I add them?
3 and a -4 when you add them. Let's see here. So if you had 3 and -1.
Yeah, -3, -1.
Yep.
So my factors, I could start here, but because my leading coefficient is a 3, I have to do this like that. And so this reduces to 1. And this becomes 3x minus 1. So then I have to solve for the zeros by setting each one of my factors equal to 0. So there's my second one. I had 1 before. So now, so far, I've gotten a -5 because that was given. I got a 1 using synthetic division. And now I got a 1 from factoring. And then I'm going to set this one equal to 0. And that's my fourth and final rational 0. So in fact, my answer is B. But so now you've seen it graphically on Desmos. Okay, so there's my -5. Here's my -1, or here's my +1/3. Oh, I don't have to have that one, sorry.
Yeah.
Because it's not irrational. And here is my multiple of 2, because it dips down, touches the x-axis, and goes back up.
Gotcha.
It's a multiple of, that's why it's a multiple of 1. So this is it graphically. This is it mathematically.
So about the multiple 2 on Desmos, I'm still a little buzzed about that. So you got the multiple of 2 because when it goes back up, it could be 2, or?
No, the multiples of 2 means, basically what that means is that this is a factor. Oh, please. That right there is 2. When it just touches the x-axis and goes back up, it means it occurs twice. So when it's a multiple of 2, that means that 1 is a rational 0 of this equation twice.
Okay. So in that,
the multiple of 2 means it happens twice.
So if it went back up and then back down again, and it happened again, then that'd be a multiple of 3.
Yeah, but that's typically not going to happen. But like, let's see. Let me try something. You know how let's see. Let's. Oh, hang on. It's too hard to type on the weird board.
Yeah, I understand.
X squared minus 4x plus 4. All right, just to give you an example, on this one right here, basically what you could say is that this is that it's a multiple of 2 because it touches the x-axis and goes back up. So 2 by 2. Does that make sense? Or no?
Yes, ma'am. Yeah, I can't see the Desmos calculator. So.
Oh, you can't see it?
No, ma'am.
What are you seeing?
I see a picture of your face and some circles around it. Like, let me see. I'll show you so if you. There.
Let me go back and see what you're showing me because I can't see. Yeah. I can't see what you. But so you can't see the Desmos thing very well?
See the Desmos. I can see the Desmos right here really well. But when you turn off your camera like this, whatever you use as your Gmail or Google Classroom account, like I use this Pareto.
Oh, yeah?
That's what I see. I'll turn back on my camera.
Oh, okay.
Alrighty, so I think...
You only see me?
No, I see the Desmos thing now.
Oh, okay. All right. Oh, I guess when I'm talking, it switches back over to my face. Does it?
No, it's like you have to turn off the camera, and when you do that, it switches over, but I don't know, I think it's all good now, so if it ain't broke.
Okay. All right. It's good?
It's good.
Okay, good. But I guess what I'm trying to say is that a factor will be a multiple of 2 when it touches the x-axis and goes back up. I can't see where it would make another reverse. I guess it possibly could. I'll have to do a cubic and see if it will. I don't know.
I mean, it's okay. I mean, you don't need to, so I think I got it pretty good.
I was going to say the only other thing. Oh, let me try this. Let's see what happens if I do a perfect, the difference of 2 cubes. X 3 minus 125. Didn't do anything. Should. Oh, yeah, it did.
Oh.
I bet it's too big of a cube. That's what it is. Let me try 8. No, I guess when it does that, it just crosses through the 2. So I guess it would cross all the way through and come back down because that is going to be a triple. It's going to hit 2, 3 a couple of times. So. But with regard to this one, so if you were graphing it, you could actually look on your calculator and figure out where it's crossing these, and that would be your rational zeros.
Gotcha.
But if you needed to figure them out, you could use, did you like synthetic division better than long division?
It's kind of like the lesser of 2 evils. I understood synthetic division.
Okay. My husband's laughing at you because he's not a math person either. And he loved that you said the lesser of 2 evils.
Yep.
That's so funny. So, yeah, I think Adriana was the only person that actually liked long division better than synthetic.
Really?
Yeah. Wow. She likes that better. But I think everybody else likes synthetic. So, but that's how you use synthetic division to get all of your rational zeros.
Gotcha. I think I got it pretty good.
That would actually happen also. I don't think we put this on the final, but you could use synthetic division to get down to where you might even have imaginary numbers.
Oh.
Yeah. But I don't think we did that on the final.
Thank goodness.
Yeah.
So,
I mean, number 18, I guess you'll just know when you get to that. You could try it on your calculator, and if you can't really see where it's crossing the x-axis, then you're going to probably have to apply that synthetic division.
they also have a cursor, kind of like what you have there.
The trace?
Yeah, the trace.
Yeah.
Or if you get it on there, you can get some pretty accurate.
Yes. You could definitely use trace. If you're good with the trace function on there, then you could rock and roll with that. That wouldn't be a problem.
Mm-hmm.
Because the whole concept of factors crossing the x-axis and rational zeros, they're really all the same thing. It's just a different expression of the same thing.
Mm-hmm.
Okay?
Gotcha.
All right. Does that help?
Yes, ma'am.
Okay, cool.
So I do have one more question about, this is mainly about logarithms. And
Okay.
reviewing logarithms. Well, first, about the 25, find the inverse of each function.
Yes, sir.
Can you walk me through that? I'm a little, fuzzy
Hazy
about
on
that.
that. Okay, I'm gonna write them down, and then I'm gonna switch. I'm gonna write them down on a piece of paper because I can't see this.
Yes, ma'am. It's Miss Sparks on Math Lab. Yeah. Sorry, that was my mom.
Oh, that's okay. Does she think you're just talking to yourself in your room?
Yeah, just talking to myself in my room.
Oh, she's probably saying, Walker, honey, I think you've studied too long.
Yeah. Why don't we go see a doctor real quick, you know?
Yeah, you're starting to talk to yourself. How many of y'all are there?
There's 3 of us. There's Emily, and then there's Sarah, and then there's me. Sarah actually is back home from college for the holidays. She just got finished taking her exams.
Oh, okay. So you're the baby Walker?
I am. I'm the baby, and I'm the last one to be out of the house. And it's crazy because Emily's a senior this year.
Yeah.
Mm-hmm.
Yeah. Momo's our baby. I was the baby of our family, but I was the baby of 9.
Whoa.
Yeah. So true.
Yeah,
whoa.
Yeah, it's a shock when the baby kind of grows up. For me, I am going to be driving myself to the orthodontist. I think I told you that I'm getting my braces off, and it's always kind of been a little bit of a shock. It's like, oh, whoa, you're driving now.
Yeah.
To them,
I know. That's kind of how we felt here when Momo started driving. It was like, oh.
Is she a junior or a senior?
She's a junior.
Mm-hmm. So maybe she's going to be graduating 2 years from now. So, oof.
Yep. Yeah. So it's crazy. Okay. So once again, I go through all the painful steps, step by step by step. So the first thing I do is change my fancy h of x to a y equals, and then 5 root negative x minus 1 over 2. Then the next step, it's to swap places with my x and my y. So then that becomes x equals 5th root of negative y minus 1 all over 2. And that was supposed to be encompassing the whole thing. So what I want to do, I'm trying to get y all by itself. That's the goal. All right?
Mm-hmm.
After I've done all of this fancy stuff. That's the easy part. But a lot of times when I go step by step by step, it kind of, okay, I'm getting this. It builds my confidence, you know? So now what I want to do to get rid of that 5th root, what I have to do is raise both sides to 5. So then that gives me x to the 5th. And then I have negative y minus 1 all over 2. Okay. So now, once again, I'm just going to apply the principles of PEMDAS in reverse to get rid of all of those things that are surrounding the y. So I'm going to multiply both sides by 2 since they're being divided by 2. So then that would leave me with 2x to the 5th equals negative y minus 1.
Gotcha.
And now I would add 1 to both sides. And that's going to give me 2x to the 5th plus 1 equals negative y. And now to get rid of the negative, I would multiply both sides by, or divide both sides by a negative 1, which that would leave me negative 2x to the 5th minus 1 equals y. Now I'm going to switch back and say h inverse of x equals, and you can either write negative 2x to the 5th minus 1.
Gotcha. So I think that would be letter A, which is 1 minus 2x to the 5th.
Yeah, I think I was remembering that to be the answer, so I'm trying to see. Oh, I would have, well.
Why don't I do the negative 1? Because
did I write something down wrong?
I don't think so.
Yes, I did. Right here. This was a plus the whole time.
Oh.
So this
Gotcha.
would have been a minus.
And that would have switched it up a little bit.
Mm-hmm.
Gotcha.
Right?
Yes, ma'am. So then if you were to write some of this down. Alright, so on that note, if we were to do number 26.
All right, let's walk through it. A lot of them said they felt like 26 was harder. So let's you and I walk through it together.
Okay, so if you were to change it all up to where it'd be.
Do you remember this is the one that I did one way and LG did the other?
Oh, yeah.
Okay. And most everybody liked LG's method. So, we'll talk about, when we get to that point, we'll talk about her way, we'll talk about my way, and then you get to pick what you like better. Doesn't offend me at all.
Yes, ma'am. So, with the way I was going to do, like, to where it's x equals 4 over y plus 1 plus 3. So, the first thing I suppose you would do is subtract the 3 from both sides. Should be x minus 3 equals
okay, hold on,
4.
let me catch up to you.
Over. Take that and you'd multiply 3 by both 1 by both sides to get
Wait
rid
a
of
minute.
Huh?
We're here, right?
Mm-hmm.
Is that where you are?
Yes, ma'am.
All right. Now, what she did, because you can't separate that y plus 1 because that's one solid term. So what she did was multiply both sides by y plus 1.
Gotcha.
So now, and then let me explain, and then I'm going to show you my way too. So she got that. So it looked like this. Okay?
Mm-hmm.
And then she divided both sides by x minus 3.
Oh, I see.
And then she subtracted 1. You just have to make sure at this step right here that you don't FOIL, that you just keep them in terms. Does that make sense?
Yes, ma'am.
So that should be one of the answers, is it?
Let me check.
Yep.
Yep.
D.
Okay, so can you scroll back to the work page? So when you were doing that, she multiplied both of them, and then She subtracted them?
No.
No.
Right here,
Mhm.
she
She
divided both
divided
sides by
negative x, or like x minus 3.
yeah, because these are terms.
Mm-hmm.
Oh. These are terms. So she knew she had to get this y plus 1 all by itself, but she knew she didn't want, like what I did was raised both sides to a -1, which gave me the inverse of both of them. So, but most everybody said they liked her way better. But you just have to remember to keep it in terms. So she knew she was trying to get this one all by itself, right here, all by itself. So if she's trying to do that, then she needs to get rid of this one. And to get rid of this one, these are being multiplied, and the inverse operation of multiplication is division. So she divided both sides by x minus 3, and that's what gave her 4 over x minus 3, and isolated this y plus 1. And then she only has to subtract 1 from both sides. Does that make sense?
Yes, ma'am. So no, I'm just came in.
Oh, that's okay. Okay. Do you want me to see if we can find another example that's close to that?
No, I think I got it actually pretty good.
Okay.
Let me see here. I think the time may be coming to a close sometime soon. So while I still have you, I would love to go over some more logarithms.
Okay. Let's do it.
Like, for instance, rewriting each equation in the logarithms for a number like 28
Okay.
and 29. That'd be pretty good. As well as expanding logarithms, basically just kind of go over all of that.
Okay. Let's see how quickly, because I know you have to leave like at 20 after?
Yeah, probably around 1:30-ish.
Okay. All right. I just don't want you to be late. So let's see how quickly we can get through them. Okay. So rewriting each into exponential form. So basically what you're looking at, if we read this, it says log base 20 of 1 equals 0. So what that's saying is that key word there is the word base. And remember, when something is in exponential form, the big number is the base. So when you say log base 20, that says, okay, that big number, when I write it in exponential form, is going to be 20. And then raised to the 0 power, because the answer is the exponent. And then the little thing that's left is the answer when it's in exponential form. So basically, when you're taking that, log base 20 of 1 equals 0. So 20 raised to the 0 power equals 1. They both are saying the exact same thing.
Gotcha.
Okay, and then to undo it, in this one, this says base 17 raised to the 2nd power equals 289. So then I would write log base 17 289 equals 2.
Gotcha. So for most of the part, you're just basically plugging in what they're giving you.
In the reverse form.
Yes, ma'am. Like, so you're plugging in the log is the base, log base 17, 289 equals 2, and then you reverse that. For instance, like if you had log base 20, 1 equals 0, then you'd have 20 to the 0 equals 1.
Correct.
Gotcha.
You're basically, all you're doing is taking the logarithm form and showing what it would look like in the exponent form. But if you hear the words log base 17, it's kind of telling you that big number is going to be 17. You know what I mean? So then you just have to logically format that 17 squared is 289. So that's the 289 fits there, and then whatever the exponent would be fits there.
Gotcha.
Okay.
Okay, sounds pretty good. So as far as expanding logarithms, How would you do that if you were to? Let me see. I'm a little confused about how you expand it. Do you think you could walk me through it real quick?
Sure. Okay. To remember what the rules are, kind of like the exponent rules and stuff. There's some rules for logarithms. So when it's added or when it's multiplied, it's addition. When it's raised to the power, it's multiplication. Very much like, remember with exponents?
Yes, ma'am.
Like it's like if I have if I have x squared raised to the third power, that's multiplication. Right?
Yes, ma'am.
I would find that out. So, and then if I have x squared plus x squared, I'm going to add those. Or no, I'm sorry. Oh, help me, Jesus. X squared times x squared, I'm going to add the exponents, and that's going to be x to the fourth. You're kind of undoing that with logarithms. So that's what logs are, is the undoing of powers. My goodness. I'm trying to scoop my paper up so I can have, there we go. So for this one, what we have going on here is we've got a multiplication between the variable u and the variable v. So I know that's going to be addition. But on top of that, each one is raised to an exponent. So I have to move that out front for multiplication. So that would be 5, because my u is raised to the fifth power, log. Maybe I should break it down into smaller steps. Maybe I should do that first for you. Let's do that. So this would be log, just for the multiplication part, would be log u to the fifth plus log base 9 v to the sixth. So that took care of my multiplication, the u times the v. All right. Now I'm going to bring these out front to take care of the power.
Oh, yeah. I think I'm starting to kind of recap some of the stuff that we were supposed to do.
Log 5 base 9 to the u plus 6 log 9 v.
Gotcha. So in that case, it should be A, if I'm not mistaken.
Yes.
Okay, I'm thinking I think I got that pretty good. I remember kind of that aha moment.
Good. Love that.
I think around the home stretch, this is the last page.
Okay, so is there a condensing?
There is a condensing. So given that information, I think I might try it myself real quick.
Okay, let's do it.
First thing.
Tell me what to write.
18 log fourth 10 minus 6 log base 4 7.
Okay.
So there's that. Let me see. I think I'm gonna simplify it to where if it has 10 minus 6, would you try and what do you do with that? Do you put 4 there or something? Or I'm a little confused on that.
Log 4. So I'm gonna have 10. And since it's a minus, that's going to be a division problem, right? Over 7. And my 10 is raised to the 18th power, because that's got to come over there. And my 7 is raised to the 6th.
Okay, I think I'm starting to understand a little better.
So it should be B.
Okay.
The minus tells me it's a division, so I should have known, because when you're condensing, you're going to look at whatever this part is, and you're going to start with that. So you would just write down log 4, because you start there. And then what's on the outside of that? You've got your 10, and then it's a minus, so that's going to be over 7 because it's a minus.
Mm,
And then you apply your powers last.
gotcha. Okay, I think I'm getting this a little better.
Okay.
As far as evaluate the expression,
Uh-huh.
I know how to do that in my calculator. I don't know, do you think, is there a
Yeah.
better way to do it on paper?
For that one right there, yes.
Mhm.
Absolutely. Because this one shouldn't take you any time. So you know your base is 3. So what am I going to have to raise this to get to 1 over 27? Well,
Let's see here.
I know that I have to raise 3 to the third power to get to 27 because 3 times 3 is 9 and
Mhm.
9 times 3 is 27. So I know 3 to the third power is 27, don't I?
Yes, ma'am.
And we probably should start to know like 2 cubed, 3 cubed, some of those.
Mhm.
Like, okay. But, oh my gosh, it's in the denominator. What do I know about exponents that drive something to the denominator?
Negative. So if you had a -3, 3 to the -3rd.
It would give you 1 over 27.
Yes, ma'am. Huh, so your answer should be C.
Yes.
Gotcha.
Okay.
Alrighty.
And then you can use the calculator for 33 and 34.
That I can do, most definitely.
Yep.
So, let me see here. I'll clear out of it. Get the log.
Do you know how to use a different base on the calculator?
Would you do the log 2, parentheses 2, parentheses, and then times?
Well, no, there should be a different base thing.
Hmm.
But I don't have my calculator in front of me to tell you exactly what steps. But if you can't do it, you can use the change of base formula.
Mm. Which one is that? Is that Q over?
That's log 6.9 over log. Just type this into your calculator.
Okay.
So log and then parentheses 6.9, close parentheses, divided by log 2, close parentheses, and then enter.
2.7865 and so forth.
Okay. So that the answer should be A.
Yes.
And is that right on the
Yes,
answer
ma'am.
guide? Okay. So if you can't, there is a change of base. There is a log with different base on some of the calculators, but you can always use the change of base formula, which is basically taking this, the log of this, divided by the log of that.
Gotcha.
So how would you put in, tell me exactly how you would write, how you would log in, do the log for the second one.
For 34, you
Yes,
take log, let me see, that'd be log 2 with parentheses over log 4 parentheses.
Yep.
So you plug that in. Log 1, there's parentheses divided by log 4 close parentheses 0.5.
Yep.
D.
Yes.
Alrighty. Thank you so much.
Not a problem. So if like I say, there is a function, it's under math, I think, but I don't know exactly where it is. And since I don't have my calculator, I'm freaking out because oh wait, good news.
You found it?
Walker, I think I just found it. I had already taken it out on the table. I hate it when I prepare myself and then I forget that I prepare myself.
Kind of like when you walk into a room and then you forget what you came into the room to get.
Yes. So true. Let me see if I can find the. I know it's here somewhere. Okay, if you hit math and then keep arrowing down, mine is A.
Gotcha, the log base.
Yeah.
Okay, yeah, I see it now. So if you hit log
So
base, that'd be 2.
Yeah, you could actually put in 2 and then arrow over and then put 6.9
Enter.
and then hit enter,
2.7865, so forth.
which is exactly what we got when we did it the other way.
Gotcha. I'm gonna keep that in my back pocket to know. both ways are pretty easy and should be pretty easy on the test.
Yeah.
But it's nice to know both ways.
Oh, absolutely. So I'm glad I had that. So we were able to cover that too.
All right. Well, I think it's getting close to my orthodontist appointment, and I'm still in my pajamas. So.
Uh-oh.
Yep. Hey, they're really comfy though. So.
Well, okay. Let me tell you, if you have any other questions since you showed up for math lab, please feel free to email me. And if I won't be able to get back on math lab probably today, but what I could do is work it out, take a picture of it, and I'll email it back to you.
All right. Thank you so much. Oh, also, I do have one question. Is there any way, is the bonus for the finishing up the review packet still available? Or
I will have to check with Miss Stone and see what she's doing because we're trying to do the same thing for both classes.
Gotcha. All right.
So, but I'll remember that you showed up for math lab, and I'll remember that when I'm grading. I promise.
Thank you so much, Miss Sparks. This has been amazing.
Not a problem.
It's really going to help me on the test.
Yeah, not a problem. I know you're going to ace it. You're going to do great. Drive safe to the orthodontist, and I'll see you tomorrow.
Bye, Miss Sparks. Thank you.
Mm-hmm.